afternoon, everyone. As Noah mentioned, I'm Denise Graves. I'm the Commercialization Program Director of a translational research program focused on transportation and mobility at the University of Michigan. And I let my two panelists introduce themselves today. Go ahead.
I'm Shawn Kerrigan, COO and co-founder for Plus. We are an AI software company based in Silicon Valley, working on ADAS and fully L4 driverless applications within the autonomy space.
Great, thank you. Lazaar Lewis, I lead product management and marketing for our central compute platform at Ambarella. I have experience in consumer electronics and semiconductor and automotive. Ambarella is a semiconductor company preparing SoCs, and we are partnering with Plus to bring autonomous driving stack to the market.
Great, thank you. So we have some questions here that we will discuss, but there will be a code on the screen shortly where you can log in your own questions, and we will get those right there, get those weaved in as we can. So let's just get started here. This question is for both of you. So the transition from hardware-centric to software-centric vehicles is a transformative change for the automotive industry. We've seen a number of delays across many OEMs in launching their next generation of electric vehicles. What's making this transition so challenging? Shawn, do you want to start?
Sure, so I'll focus on the software-defined vehicle part of that, because oftentimes that's coupled with those electric vehicles. And within that domain, I think there are a couple of major challenges that have led to some of these delays. So first of all, when you move from the current distributed architecture for all the ECUs throughout the vehicle to a software-defined vehicle based around a single large ECU, that translates to some fundamental differences in terms of how you architect the software. So that translates then to differences in terms of the skill set needed to do it, the tooling needed to do it, the full tool chain to support that. And so I think there's some really big sort of paradigm changes that need to take place as companies look to make that transition. Second, another part that's tied to that is usually putting in more advanced ADAS systems, because that's a growing consumer expectation when they have these new electrified vehicles to also expect more advanced capabilities from the ADAS systems. In order to build that is also another paradigm change and a different one, because oftentimes those are based around AI and deep neural networks. So that again requires different skill set, different tool chain, different mindset. And so both of those together, I think, have made this particular transition a little bit more challenging than some expected.
Great. So before we ask the next panelist the question, you talked about a paradigm shift. Mm-hmm. So can you give us a couple of examples of what that might be?
Certainly. So as you think about how you go about architecting some of the software that go on to these embedded systems, they tend to be smaller self-contained systems. Rather than on software-defined vehicles where you have a large ECU, you're running a much larger and more sophisticated software system with a lot more components. And so how you think about architecting that, how you think about testing that, how you think about doing all the engineers that are feeding code into that is different. Mm-hmm. And then another paradigm shift is on the ADAS side with a neural network and AI-based approach to building these systems. It's a very different paradigm. Rather than going from sort of feature and functions to then discrete algorithms that you then have certain test cases around, it's a much more data-driven workflow where you need to go out there and really understand what are all the scenarios that need to be handled, mm-hmm. How do you collect data that relate to those scenarios, and then how do you bring that all together into a data-driven workflow to help you improve the quality of the system. Mm-hmm.
Great, so the use of large language models and things of that nature, yep. So to speak. Okay, great, Lazaar?
Thank you. Agree with what Shawn shared, and some details I can share about the challenges is there are challenges both from a hardware and a software side. On the software side, the OEMs and the tier ones that are providing solutions here are struggling maybe on three dimensions. One is just the technology, that they don't have the technology to deliver a robust experience. In some cases, their bar is to have same experience as the previous model, and they are struggling even to get to that level sometimes. And the second is, in terms of if they don't have the software, then they're getting it from partners, and the business model is such that in some cases the partners are providing a black box solution. And so it has corner cases that are not being able to overcome in the time frame, and that is causing delays as well. And the third thing on the software side is resources, where there is always challenges with the resources to do this. On the hardware side, there are things like the architecture that they chose maybe 3 years ago is not scaling to meet their expectations as they are implementing it. So it's there's a challenge there. Secondly, on the hardware side, there are sensors in the car. Depending on the different car lines, they are in different locations. Now, just creating a software to support those various locations and the angles at which the radars are located based on the body of the car is a challenge as well that takes some time. And the third thing is on the hardware side would be power consumption, where they are trying to put everything in the software side to meet the target specification, but the power consumption is higher. And so now this is causing them to defeature some things, or alternatively delays of up to a year to bring the product to the market. So it's some real challenges, and I think that's where we are able to come in and help in several of those cases.
Sure. Now, we'll get to this conversation in a little bit, but the partnership, but you talked about resources and engineers. So I'm just curious, I'm going to go off script here a little bit. I'm assuming that's a talent play. So I know that you're in the Bay Area, so there's probably lots of engineers, but are your organizations, and even through the partnership, doing anything creative to attract that talent to help alleviate some of that resource constraint? Just out of curiosity. You can say no if you're not.
So we always try and do things to attract the best talent. There's always a big competition for top talent. I think there's a lot of fantastic talent in the Bay Area, but we've tried to build a company that's an exciting place to work, a place where engineers have opportunity to explore their interests and work collaboratively across a lot of different domains. And I think it's some of those cultural aspects around how you build the company that can help attract in top talent.
Cool. Lazaar, anything
else? We are trying to help in that regard because there is talent in the Bay Area, so we can take on some support activities where the customer would like us to help in that regard and be able to support it that way.
Excellent. Okay. So Shawn, the next question is for you. Higher levels of automated driving features are becoming standard in most cars. How do you see these two trends of autonomy and software-defined vehicles coming together? And secondly, will autonomy help speed up the software-defined vehicle transition, or will it add another level of software complexity?
I think that's a great question. I would say probably both. I think that this advanced autonomy that people are growing to have is an expectation within the system. It does add complexity, but it's also one of the things that I think is helping propel the notion of the software-defined vehicle forward. Because what consumers are asking for is not necessarily just a software-defined vehicle. What they're asking for are the more advanced capabilities that you can get from that sort of system. The more advanced types of safety and convenience features that can come from that. And so in that way, I think it's helping propel it, because the way to achieve that level of autonomy and automation is through having a larger central compute with more advanced AI and algorithms running on it. And so that's how you can really get to this next level of safety and autonomy. But to do that, you need to have that central compute, and you need to have the sensor streaming the raw data to that central compute, and you need to be able to update that software. And those are all sort of core components of what it means to have a software-defined vehicle. So I think the two trends are actually pretty tightly linked.
Okay, great. Lazaar, anything to add?
Yeah, when Shawn was sharing that analogy, what came to my mind is, I tend to rent cars either when I business travel or personal travel. And there was this car where I was driving and I got into a traffic situation and the speed was dropping at lower levels. And I was in adaptive cruise control and the car just decided to not do it. And I was wondering what happened here. So next time I watch it, a small beep and then it goes away. So when the speed drops below 30, adaptive cruise control is disabled.
Oh.
And I'm thinking that's when I need this feature.
Yeah.
Because I'm a
Good to know.
traffic jam, right? And so this expectation of autonomy that Shawn talked about is happening, and that I think so. The SDV is going to be able to bring very robust hardware and software to the car to help deliver that to the customers.
Sure. Great. Thank you. All right, for both of you, how is AI going to impact the next generation of passenger cars? What specific applications of deep learning, end-to-end learning, and Gen AI are your respective companies already incorporating into your technology? So Lazaar, let's start with you.
Great, thank you. Today, when you take an experience on the cars, what you would notice is somewhat of a robotic driving experience. It is, lane keeping might hunt between the two edges, etc., So to go from a robotic experience, because that's rules-based, to more a human-like, I think that's where AI comes in. And as part of coming into AI, there are multiple steps the industry is taking into account. One is they were using traditional convolution networks before to deliver that experience. Now they shifted towards more using transformer networks, where transformers were originally defined for language translation, but the car navigating through the roads is somewhat of a translation there. So that's helping. And so the new concept you hear now is bird's eye view. BEV used to be battery EVs, but that same word is now used for bird's eye view perception using transformer networks, and that's a trend. And then there are advancements from there to go to end-to-end AI. Because rather than having the walls, maybe you can go there. And I'm also starting to see Gen AI, large language models, coming into play. I think there's going to be a spectrum in use of large language models, Gen AI there. Some companies might choose to do all there, but the compute resources are very high. So I believe there will be a hybrid system where there is an automotive network that's trained on the task that's going to do the main driving, but it can get challenged in corner cases. And I think there can be a Gen AI or a LLM that is running and can provide that insight. This is what I see, and then the automotive network can take over and continue the driving. So it'll be a hybrid, and so we're kind of looking forward. And our platform is able to support all these new trends, and that's one of the reasons we are seeing a lot of interest, and so looking forward to it.
Great, Shawn?
Yeah, so as an AI software company, we use kind of all the above in terms of Gen AI and transformer-based networks and so on. I think that one of the areas where we've seen the most commercial traction in terms of interest of the specific application I'll talk about is the transformer-based BEV models or bird's eye view models, because that enables just a new next level of performance in terms of understanding the world around the vehicle that can really enable these next generation ADAS type systems. I liken sort of the performance difference you see there is a little bit like the performance difference you see from going from the type of chatbots or voice assistants we've been working with for many years to now what you saw when OpenAI came out with ChatGPT, right? It's just a very different level of performance and capability because now you have a new larger based network that just enables just a very different level of performance. And so as we've seen many OEMs and tier ones that are interested in building these next gen ADAS systems, and they want to build sort of custom performance and characteristics into those systems that kind of fit the feel of their vehicles for their customers. But one of the areas where I think they need the most help is really understanding the world around them, right? And so if we can provide them that transformer-based BEV type model, that enables their teams to then build out the driving policy that fits with the vehicle the way they see it. Just because, as we talked about earlier, some of the defining characteristics of many of these new vehicles, it's not about horsepower defining a premium vehicle anymore. It's about things like battery range and ADAS performance. What sort of safety and sort of comfort features does your system have? And how tuned are those things to the vehicle itself? And so for OEMs and tier ones that want to build out that sort of customized capability, having really robust perception can really enable that next level of performance and customization.
Great. Now this is a question that came up in a previous panel we didn't get to, but I'm curious, when you talk about Gen AI, OpenAI, large language models, is there any data that is getting created from other industries that could be used in your companies to support the automotive industry?
Yes, I mean, I think there's actually a really exciting trend right now in terms of companies releasing large models out there for public use and for commercial use. And so we can make use of some of those in terms of the work we do using model distillation techniques, which is where you take a large network and you're able to distill out key components of it into the things that you have. And so we use that type of technology as we build out our transformer-based BEV models. And that, again, has allowed us to take that base model performance and move it even to another level again.
Yep. Great. All right, let's go ahead and take a question that's been shared here. Do you think end customers or consumers know or care what a software-defined vehicle is? And how should OEMs sell the benefits to the customers?
So I don't think consumers care in terms of software-defined vehicle. I think that goes back to what I said earlier in terms of how ADAS is helping push software-defined vehicles. What consumers care about is how much does the vehicle cost? And so with software-defined vehicles, you can bring down costs. And then what consumers care about is what's the performance of my ADAS system? What level of safety does it bring? What level of comfort? And there again, it's with these software-defined vehicles that you can host these types of larger, more sophisticated ADAS systems that build on AI. And that, I think, is what consumers care about. And so I think what OEMs would be selling is the benefits of cost and performance.
And trust, probably, at the end
Yeah.
of the day, right? Lazaar, any thoughts on that?
Yeah, I agree with Shawn. I do believe that there is less being done today to promote the autonomy and the assisted driving features. Like when I'm in the market to buy cars, recently they talk a lot about infotainment. You can get a bigger display, this and that, that, right? But nobody tells me that you could upgrade, or these are the features that are coming in. So I think there is more they could do. That will raise the willingness to pay by the consumer, and that can then allow the OEM to put additional cost into those systems, right? So there is a cycle that hasn't fully, that virtuous cycle isn't fully running right now. But I also feel the trends of the robo-taxis in San Francisco. People are getting used to this autonomy. They're trusting it. And so now they probably will ask for, look for it when they buy the car, right? So there's going to be some pull directly, but I think the OEMs can really take advantage of marketing strategy to gain some pull as well.
Sure. Although I rode in my first Waymo over Labor Day weekend, and that was freaky, just from the standpoint of there's no driver. And you're greeted by this computer screen, and it was just eerie, I guess, for me. But I'm sure you get used to it.
But you'll get used to it, and it will build that level of trust.
Yeah.
And I think that then builds confidence that these systems can drive safely. And then once people get used to them driving safely, I think that's a part of what feeds into the increased demand for this technology in their own cars.
Sure. Yep. I agree. All right, for both of you, the next question is, in the age of software-defined vehicles, Silicon Valley is now a hotspot for auto tech. As two Silicon Valley-based companies, can you talk a little bit about this trend? What is driving this trend, and in your partnership with OEMs and Tier 1s, what are the key learnings from these new models of collaboration?
Shawn?
Okay. I'd say that I think we agree that there is a really big trend there, and I think that there's a lot to be learned from both sides. I'd say within Silicon Valley, there's a lot of expertise on how to build large-scale software systems, how to build large-scale AI systems, how to build those systems in a way that you can then maintain and update them and upgrade them and have them be reliable. So I think it's really that software and AI technology capability that's really important to the future of vehicles. On the OEM and Tier 1 side, I think there's also a lot of really great things that come in. In particular, I think the thing that we've seen a lot of value and help from is the structured processes and thinking around safety. How do you make sure that you have a really bulletproof safety case and that you've really thought through all aspects of that before you release something? And so I think it's a lot of those safety and quality standards and ways of working that I think bringing those two things together is really powerful. And so that's why I think we're starting to see more and more collaboration between OEMs and Tier 1s and Silicon Valley technology companies, because it's the combination of what they're each great at that will, I think, enable these next generation of vehicles with all these new capabilities.
That's interesting. I've not thought about it that way before. Lazaar?
Yeah, to add to what Shawn shared, one of the things that the Silicon Valley companies are promoting is use of stronger algorithms, more complex, stronger algorithms. Maybe the trend before was using more sensors, higher resolution to achieve to solve the problem. But now there is a trend that the Valley is bringing that, and so the infusion of those two will help. Secondly, there is also recent efforts in Silicon Valley to bring these to embedded systems, because they are realizing the power consumption and the consequences of that running it on big computers, right? So there is, when I talk to various customers in the Valley, they all are in that journey now. Now we got to get this in embedded systems, and they are working on implementing that, including I think Plus, and so that is going to also be pivotal in helping the industry.
Now, I was in a panel earlier today, and it makes me think about cybersecurity. So when we talk about these embedded systems and we talk about software, do you think about cybersecurity, or is that something that the OEMs think about? Just curiosity.
We think a lot about cybersecurity. I mean, cybersecurity is one element of the overall safety case. I mean, cybersecurity at the end is really about how do you ensure that your system is safe, even when up against a malicious actor that's trying to make it do something unsafe. And so it's a critical part of that overall safety equation.
Yes, we have experts in that as well, because we have to put enough things in the semiconductor to support that trust and verification. So we do have experts, and we have to meet certain requirements along those lines. So we work on those as well. It's an important part of our work.
Great. All right, so let's take a question from the audience. So what is the hardware software limitations that you foresee as we step into the AI space? Lazaar, you want to start?
Yeah, one of the things is, as AI is coming into play, in the cars today, there are 3 AI compute that are running. Yeah? First is the primary driving stack that is doing the driving. Second is they're always validating the next stack. They call it the shadow mode. They're running the next stack and seeing what decisions it's making. Thirdly, one of the ways these companies can improve the experience is by using their fleet to collect data. So if there is a disengagement, they're getting feedback that there is this problem. The way to solve it would be them to send a command to the car and say, when you run into this situation, just send me the video file so I can use it for data. So there is a AI as well running there. So when all these need to run, now there is challenges in getting that compute in an embedded system. So that's one challenge people are facing. They're addressing that today by maybe adding more SoCs than they thought originally. So that's one thing, but it's not cost efficient, right? So that's there. The second challenge is from just on the system side, power consumption. And it's happening today that these assisted and autonomous driving systems are having a direct impact on the range of the car because they're consuming so much power. And so it is important that we have systems that are have good power efficiency, so you can gain some range in the car, and also OEMs can gain some savings on the battery as well. So there are technologies that we are working on to bring these to the market. And maybe Shawn, you could touch on the software.
Yeah, I mean, I think in terms of hardware, software limitations, I think that when it comes to AI, more compute power is always better. And you see that in terms of these larger models have more capabilities and can do more things. And so what's really important in this space is how are you able to take these advanced AI capabilities and fit them on the automotive grade compute that's available today or some of the compute that's coming. And that's where some of these techniques like model distillation from the large models that we talked about earlier really come into play, of how do you really capture the maximum value and capability out of the hardware that's available.
Great. So also for both of you, in the age of software-defined vehicles and the transition to get there, how are your customers' needs or their pain points changing, and how are you shaping your products and offerings differently? Shawn, you want to start?
Sure. So I think there are a few things that we've seen in terms of customer needs as they've shifted. So first is just around when they think about the capabilities that go into these systems, right? They're looking for systems that they can update over time. Because what customers want is both this advanced capability and then also the ability to update it over time. And so that becomes one thing that's really important. The second is then ability to provide this type of really advanced functionality that improves the overall safety and comfort of the vehicle. And then the third is transparency, because one of the differences as you move from this model with lots of distributed compute to a large central compute is now that central compute is running the ADAS stack, but it's also running other things. And so in order to ensure the overall safety and reliability of the full system, it's important to provide a high degree of transparency into what is your system doing, right? How does it work? What is it doing? So that you can make sure that integrated whole works, right? And so I think it comes back to then this sort of advanced capability combined with the ability to do updates of that and the ability to provide a deep level of transparency into how your system is operating and what it's doing.
Great. Lazaar?
Yeah, those are great points, Shawn. One thing I could add is our OEM customers are looking for scalability because they have different car lines and they need to deliver experiences that are for mass market, medium and premium markets as well. And so they're looking for platforms that they can use one platform, one software architecture to develop that entire experience. And so what we're doing more and more these days is we are working with our tier ones and OEMs to look at their product lines across the car lines and coming up with where to draw the lines in terms of what kind of sensors do you need for the mass market? What kind of sensors do you need for an advanced L2? And then what kind of sensors do you need for L3? And then defining products, both from a hardware and a software side, to meet those needs. And so that is an important pain point today, because in the distributed computing world, they were buying different ECUs for different experiences. So they were all different technologies and different software. And so as they are trying to bring it together, that is something that we are able to serve better.
Yeah, interesting point. And that leads us to a good question here. Should you believe, or do you believe, that customers should pay for software-defined vehicles? And who will benefit from the software-defined vehicle? Is it society or the car owner?
I would say, going back to like why are software-defined vehicles taking root, it's because of the cost savings potential. So I don't think customers should be paying more for software-defined vehicle. I think it's actually a way that we're going to be able to help drive down the overall cost of vehicles. And then in terms of who benefits, society or a car owner, I would say both. I mean, safety is something I think benefits everybody, both the car owner and society. And so I think the benefits that people get from this type of technology and the improvements that as we make the road safer is something that really benefits all.
Lazaar?
Yeah, I agree with Shawn there. A different angle of the question could be, there's one trend even traditional OEMs are doing today is they are putting the ECU and the sensors in the car and going with a subscription model. And the customer is now free to select, when they want it, and how long they want it as a subscription. And so I think the customer chooses to pay for those experiences. And I think that's a new trend, which is good. This will help the industry advance further. And to Shawn's point, I think both as a user of the road, I benefit from somebody trying to be safe in their cars.
Right, absolutely.
And the driver as well.
So when we think about this topic and all the data, who owns the data that is getting collected in my vehicle?
Data is the
Lazaar?
new oil.
Yeah.
And so OEMs want to own the data. Yeah, and so
Should they?
They are providing that experience to the customer at the end, and they have that relationship with the customer. And so I think they will make the best decisions on how to use the data, because they are in the relationship for a longer term. And so I'm okay with them owning the data. In some scenarios, if they don't have the technology to implement software-defined vehicles, then they are leaning on others to do. And so they then collect data and own it.
Yeah, Shawn, do you have
No,
perspective?
I would agree with all that, and I think that, there's obviously some privacy aspects that need to be addressed as part of that, but it's also that data is what is enabling them to make those vehicles even safer. That's what's enabling them to make sure they fully handled all the scenarios and things that happen out there on the road, and that's what enables them to really learn across all the vehicles to have the safest possible system. And so there is, I think, a very positive feedback loop to that data sharing.
Great. So next question for both of you. Ambarella and Plus are engaged in a partnership. Can you share more about how you're working together, what prompted the partnership, and also the role that the partnership plays in developing and deploying next-gen software-defined and autonomous vehicles? Lazaar, you want to go first?
Yeah, I can start. As enabling technologies like we talked about, the bird's eye view, the transformer, the Gen AI, we want to bring that technology to market, and Plus is using that transformer technology in their bird's eye view, like Shawn talked about, and so there was a natural interest in partnering there, and so we are working together, and we look forward to sharing some of the technologies that we are preparing in future events.
Great, Shawn?
Yeah, I agree with all that, and I would just say that I think it also ties to the trend that we've seen in terms of many OEMs and Tier 1s wanting to separate the hardware and software in terms of SoC and the software that's running on that. And yet they still want to see a tight collaboration between the hardware and software providers to make sure that you capture the maximum performance. So as we talked about earlier, right, there's inevitably a constraint in terms of the amount of compute power you can put on a vehicle as compared to a data center. And so making sure that you really are able to fully optimize the system and really capture the full capacity and capability of what could be delivered on a vehicle is important. And that's why I think these types of collaborations are important to really make sure that we jointly deliver the best solution to the customer.
Great. Now, do you find, I know that sometimes with the OEMs in the years past, it was, we will build everything. But it seems like with all the new technology and AI and everything that's going on in the software-defined vehicles, they're now more interested in partnering and having others help them build this out. Are you seeing similar things going on, or?
Yeah, I think we're seeing much of that trend as we talked about earlier in terms of the trend of really combining the OEMs and tier ones with the software and technology from Silicon Valley. I think that's a great trend because of the difference in terms of core capabilities. And when you put those together in the right way, it's really a powerful combination. And so, yeah, I do think that there's a bit of a shift in terms of how people are approaching that.
And it helps alleviate the talent, bottleneck as well, I would think.
Yep.
Yeah. All right, Lazaar, this next one is for you. Automated and autonomous driving requires significant compute processing power, yet especially in EVs, you also have to balance overall power consumption for the vehicle. How is Ambarella addressing this?
It is a huge challenge. I think I rented a car with the front camera for driver assistance, maybe 2017 here, and it was blowing so much the fan was blowing so much hot air that I got to crank the AC to keep the temperature comfortable, right? So this is a challenge in terms of performance. And we talked about earlier on how this impacts the range of the vehicle. So what we are able to show with Ambarella's technology is Ambarella for 20 years have been providing very high performance at low powers for products that need very good performance, long battery life, and thermally the product has to be comfortable to use. So that's from the learnings of that, we are doing AI compute in a different way, where we are able to deliver that high performance at low power. And by doing so, we are able to extend the range of an EV by 50 kilometers compared to a system that they're using today. That is very significant. People will be willing to pay thousands of dollars for that. Alternatively, our OEMs can now create different versions, and they can create a version where they can reduce the battery to compensate for that. And this reduction of the battery is helping them save around $1,000. So there is very meaningful, tangible benefits to our customers from the benefits we bring on the power. The last point is, if the platform is not power efficient, now you need to liquid cool the system. That is like data centers and things. Unfortunately, traditional combustion engines today don't have liquid cooling in their architecture. And so they cannot use liquid cooled systems. So that's another area where our solutions, the central compute platform, range from passive cooling to air cooling. And so we are able to allow customers to do without liquid cooling. And this way, there is also maintenance, lifetime maintenance on liquid cooling, so they can save on that as well. Even if there is an electric vehicle, there is liquid cooling, they want to limit where they need to take that liquid to cool systems. So it's an important challenge compared to the scalability as well. So that's one of the reasons our customers in press releases highlight their benefits being a scalable solution, power efficient solution.
Great. Shawn, any thoughts on that topic?
I would agree with everything you said. I think you covered most of the key points, yeah.
Great. All right, let's take another audience question. So since Chinese and European markets are very different than our traditional US consumer, what SDV solutions are most attractive to the North American customer? Shawn, do you have a perspective on that?
Yeah, I would say so. So we today operate in US and Europe, and we formerly operated in China. So we've had a perspective in the different markets on that. I mean, I think while there are some differences across the market, I think the consumer demand for more advanced ADAS features, I feel like is pretty uniform across those markets. So while there are some differences in terms of different adoption rates for some of the technologies like electric vehicles, there's some differences in terms of some of the regulatory regimes that apply in those markets. The core interest from consumers, I think, isn't so much in software-defined vehicles per se, it's in the features that they provide. It's in the lower cost that can be achieved for the overall system. It's in the improved safety of the overall system, and it's through the enhanced sort of convenience features that you can get out of these systems.
Lazaar, any thoughts on that?
Yeah, what I learned on a recent visit is Europe, people like to drive their cars mostly. They are buying the cars for the driving experience, but they do like assisted technology when they want to. I think in the US, there's a lot more traffic in cities during busy hours, so the need for assisted driving and automated driving is more. So I would say it's more here than the Europe in that regard. From a safety standpoint, like Shawn talked about, There is a strong interest in the U.S. to protect the pedestrians and the bicyclists on the road, right? So there's new regulations coming in 2029. The cars have to be able to see a person standing next to the car, separate them from the car, and be able to stop. So there are new regulations that are coming into play, and these will drive better autonomy, better safety, emergency brakings, et cetera.
Great, thank you. So Shawn, Plus is already deploying autonomous driving technologies with CV OEM partners, including Hyundai Motor Company, Iveco, and Traton Group, covering L2 plus to L4. Is your technology deployment in commercial vehicles adaptable to passenger vehicles? And what is your approach to scaling your technology across the different levels of autonomy?
It is, I mean, that's in fact what we did is, so we started originally with L4 within commercial vehicles. And what we found is that there was a great application for that core capability set to provide more advanced levels of ADAS. So it's much of the same underlying AI system, the virtual driver capability, applies into ADAS as well, and from there as well into passenger vehicles. Because at the end of the day, the ability to perceive the world around you and understand what are all the different actors and things out there going to do, and understand what are the safe things for you as a driver of a vehicle to do is actually consistent. And I think that what we found in particular as we've brought that technology into the passenger vehicle space is that people are most interested in the core perception capability because of the, as more OEMs and Tier 1 see the need to customize that ADAS as part of the vehicle to match the look and feel of the vehicle and the expectation of their customers. The part that they need the most help with is really understanding the environment around them so that they can then build those driving functions safely. And that perception capability coming from a L4 heritage where there's a really high standard in terms of what's expected in terms of performance, and the diversity of data that we've developed as we've operated this in North America and Europe and Australia, Japan, right, is that diversity of data across different environments really leads to the overall robustness of that perception system.
Great. Lazaar, any thoughts?
Yeah, no, that's very translatable between industries, and the only difference is based on the size of the vehicle, how you negotiate the other actors around the road, because you have different dynamics. But from a technology standpoint, it's very translatable.
Great. All right, so some final thoughts. What trends should we expect to hear more about in the coming year as it relates to software-defined vehicles? Lazaar, you want to start?
We talked about how there is going to be more pull from the consumers on the autonomous features, so that is something that is happening, and I can see that the OEMs are starting to be concerned about their model cars in 28, 29, if that would be able to compete with other cars that are coming in from other places, right? So there is that concern and there is reaction. And so there is going to be a trend in adopting more robust systems and software.
Shawn?
I would say that's probably the key trend, which is the adoption, the commercialization release. There's been a lot of talk about this trend in the past several years. And there have been some delays in terms of it getting rolled out, and that's led to some people wondering if this is the right approach. But I think now as people are figuring out and getting over the hump on some of those changes that we talked about earlier that have made it more challenging than originally expected, I think that at the end of the day, it is going to bring the value that everybody saw going down this path. And I think that as you start to see these come out in real production vehicles in the coming years, that trend is only going to accelerate.
Great. So we'll take a final question from the audience. How can the industry speed up development and validation of AI-enabled applications and reduce the cost? Shawn, you want to take that one first?
I mean, I think the key thing is to structure the right partnerships to bring that together. So we talked about earlier the partnership we're seeing now between OEMs and Tier 1s and Silicon Valley software and AI companies. And I think it's those types of collaborations where you bring together the deep experts in these different respective fields and pair together their strengths. That's what can enable you to bring this together faster and at lower cost.
Lazaar?
I was thinking the same, and to enable it, what we have done is also we have created some technology aspects that are made available to our customers to integrate and accelerate the time to market if they are interested.
Now that leads me to think about, we're pushing, let's go faster. to get stuff on the market. But what about the consumption from the consumer? Are they consuming that as quickly as you want to push it out?
What I'm hearing from my customers is that there is, they are monitoring all of this. For example, they have the hardware, the sensors, and there's a subscription model, and they are monitoring, and they are seeing more adoption, more usage. And there are some areas where it is weaker, where there is less data, and they are working on it. So I think I'm hearing more of an upward tick on the adoption.
What about you, Shawn?
Yeah, I think that I think customers aren't asking for software-defined vehicles. Customers are asking for less expensive, more capable vehicles. So I think they're less interested in terms of how do you achieve that. They just know what is the end goal that they want. And so I do think that the faster that this is brought to market and the more consumers can see that, the more pull there will be, because this is, at the end of the day, something that everybody is looking for.
Great. Well, I'm looking forward to the cheaper part to it. All right, gentlemen, any parting thoughts?
I think it's just I think it's an exciting time to be in the industry. I think this is really a time where there's been a lot of these exciting trends that are really transformational, and they've been talked about for a while, and now we're right on the cusp of actually seeing them begin to bear fruit as they start to get produced en masse.
Yep.
Along those lines, AI for autonomy and assisted driving is now more real, and there is a lot of interest and excitement around it at the OEMs and the tier ones, and so we're happy to see that, and looking forward to bringing it to the market soon.
Great, gentlemen, it's been a pleasure. Thank you for your time today. Thank you for joining us this afternoon. All
Thank
right.
you.
Thank you.